All right, one of the things that we talked about in the first part of 1-2 was evaluating a function. So if you see something like f of -2, you're taking that -2, you're plugging it in place of all the x's in the original f of x. Remember that you're placing it in parentheses. So this would be like 2 times -2 squared plus -2 minus 1. So the -2 is going to get squared first. So this becomes 2 times 4 minus 2 minus 1, 8 minus 2 minus 1, or 5. For number 2, you're plugging in a -a. So it'd be 2 -a squared plus a -a minus 1, or 2a squared minus a minus 1. And that's as simplified as it gets, so you'll leave it like that. And then for 3, you're plugging in x plus 1. So this is 2 times x plus 1 squared plus x plus 1 minus 1. And then remember, we expand and FOIL that. You can't distribute that exponent. So one way to do it is literally do x plus 1 times x plus 1 and FOIL it out. The other is use the shortcut. The shortcut is square the first term, so it'd be x squared. Double the product, so the product would be 1 times x or x. Double that, so it's 2x, and it's a positive 2x. And then square the last term. 1 squared is still 1. Plus x plus 1 minus 1. Now I'm going to distribute that 2. I'm going to get 2x squared plus 4x plus 2 plus x. Positive 1 and negative 1 can cancel out from there, or I could have kept going and then simplified. And then come on your like terms. So 2x squared plus 5x plus 2. And even if it's factorable, you want to leave it the way that it is. The only time we would go further is if it was like solve this. If it said to solve that, then I would factor, set it equal to 0. Or if it literally said factor. Oh, Kevin, I told. All right, so we're going to continue the notes on section 1-2, which was the functions that we started on Friday. So on Friday, we did the evaluate the function, and then we left off with piecewise, correct? Yes? Okay. So piecewise functions are functions that change based on the different values of x. So you'll see something like what's at the top here. This is called a piecewise function, okay? You're going to get at f of x, and it's conditional. So f of x is x squared if the value of x is less than 0, and f of x is x squared plus 2 if the value of x is greater than or equal to 0. There are 2 here. There could be a third condition, like, so you could have multiple lines there, okay? There's no limit to how many they are. But the range on the x's can't overlap. So it's not like one value could be in more than one of those. We will eventually graph these, like when we get to 1-4, we'll actually graph these. For now, we're just evaluating them. So the first thing you have to do when you see something like A, where it says f is -2, is say which of those ranges would -2 fall in? X is less than 0 or x is greater than or equal to 0? Less than, which means I use the x squared. And I literally just get -2 squared, which is 4. Then I go to B. 0. Is 0 less than 0 or greater than or equal to 0? Greater than or equal to. So I get 0 squared plus 2, which is 2. And f of 3 is 3 less than 0 or greater than or equal to 0? Greater than or equal to. So I do 3 squared plus 2. 9 plus 2, or 11. These should be easy. Mistakes made on this stuff is like people will plug it into both and then like answer 2 answers. Like that's not how that works. It's either one or the other. And then on the homework, I don't remember if you guys have this one, but it could also say something like 3 if x is less than 0. And that means if x is -1, my answer is just 3. I don't do anything with an x. I literally just get the value there. On a graph, that would be a horizontal line that goes through 3. And then it would change after that. Questions? All right, then you're going to get something that says find the values of the function such that f of x equals 0. So this is just like saying find the x-intercepts. This is just like saying find the zeros. This is like saying find the solutions, find the roots. All of those are the same thing. All we do is set our equation equal to 0. So we start basic, like if f of x equals 14 minus 2x, I would do 0 equals 14 minus 2x, and then solve my equation. Add the 2x 2x equals 14, divide by 2. And x is 7. So if I actually had drawn this on my graphing utility, the f of x is y, so this is like the same thing as saying y equals. And I could say that that's a line, and my y or my x-intercept, no, sorry, my y-intercept is 7. No, x-intercept, I said it right the first time. X-intercept, where it crosses the x-axis. All right, go to B. Start the same way. Replace f of x with 0. And then as soon as you see an x squared and an x, that's your indication you're going to have to do what? Good. I'm going to factor. What are the factors of negative 14 that sum to negative 5? Negative 7, positive 2. And then I split and solve. And I get x equals 7 and x equals negative 2. I think on WebAssign it will tell you to answer your separated by a comma, I think is how it says to do it. And C, again, start same way, replace f of x with 0. And how would I start to solve this one? Multiply what? Good. Multiply the 5 on both sides. So I get 0 equals x to the third minus 2x squared minus 2x plus 4. This time I have 4 terms. What do I do? Good. Factor. We call it factoring by grouping, right? So I'm going to group them in 2s. From the first set of parentheses, what can I take out? Good. And from the second set of parentheses, I want to take out a negative 2 because I want to change the sign, right? So negative 2. Then what's inside the parentheses is my greatest common factor, so that comes out. And what's left gets grouped together. Can I factor x squared minus 2? Are they both perfect squares? No. So if it was like x squared minus 4, I would keep going. As it stands, I can't factor it anymore, so this is where I'm going to split and solve. So I get x equals 2 from the first one. And then I'd get x squared equals 2. I have to square root both sides, but I have to remember to do the plus and minus. So I'd get x equals plus and minus square root 2. So in order, that would be negative square root 2, positive square root 2, and 2. Sometimes it will tell you to put them in order. Sometimes it just tells you to list them. And the order wouldn't matter. Now, if I had graphed this function, it would cross my x-axis 3 times. One at about negative 1.4, one at about positive 1.4, and one at 2. Questions on any of these? So again, we're gonna go further in 1-3. You're gonna even do more on these roots, but that would be your x-intercepts. Oh. All right, example 5 says, find the values of x for which f of x equals g of x. It gives you f of x is x squared and g of x equals 2x plus 8. What do we do with those? Set them equal to each other. So if x squared equals 2x plus 8, then what? Good. I got to get everything to one side. So move these over. As soon as you see the x squared and the x, you're going to have to factor. So you're going to get everything to one side. And then I'm looking for factors of negative 8 that sum to negative 2. Good. And then split and solve. To interpret this on a graph, this would be, if I graph those two separately, they would intersect at those points. Okay, that's where they would be equal to each other. All right, now we get into domain. So domain is all the values of x that your function can have. So a restriction in domain on a graph looks like a hole or an asymptote or a break in your graph. All right, so the domain of functions, the default is all real numbers, and we're going to do this in interval notation, so all real numbers would look like that, negative infinity to positive infinity, except for 3 cases. The first is if there's a variable in the denominator, and if you have a variable in the denominator, we set the denominator not equal to 0 to find out what the restriction would be. The second is if there's a variable under a square root. And for that, we set it greater than or equal to 0. And the last is if there's a variable under the square root in the denominator, so the combination of the two. And for that, we set what's underneath the square root greater than 0. So think about why this happens. If you go to the first one, if there is a 0 in the denominator, what do you get? What happens when you divide by 0? It's undefined, right? So if you were to graph this, it would be undefined at that point. You couldn't find it. For the second one, if it's less than 0, that means it's going to be negative. What happens when you try to square root a negative? Well, if you try to square root it, it's imaginary, right? It doesn't exist. And then the combination of this is if you put that imaginary number now in the denominator, it can't be imaginary, and it also can't be 0 because it would be undefined. So that's where these come from. All of these answers will be given in interval notation. Oh, okay. Good morning. So interval notation would start, let's start with like some review on that one. If I said x could not equal 1, and I want to put that in interval notation, it's all the numbers except for 1. So this is from negative infinity to 1. And then this little u means union, which means I can use anything from that one and anything from 1 to positive infinity. So when you're writing interval notation, you're saying this is what x can be. From negative infinity to 1, and then from 1 to positive infinity. It can include 1, so it gets parentheses. If I said x had to be less than or equal to 1, now it's from negative infinity up to 1. So it'd be negative infinity to 1, and there'd be a bracket on the 1 because the or equal to says I can include the 1. If it's greater than or equal to 1, now that's reversed. I put the 1 first, and it goes to positive infinity. If it said less than 1 and not or equal to, what changes? That bracket becomes a parentheses. Good. And if it said x is greater than 1, what changes from the bracket 1 to positive infinity? Good. Same thing. Good. So that bracket becomes a parentheses. Now, if you have 2 not equals, if it says x cannot equal 1 or 2, then it goes from negative infinity to the first one. So in this case, 1. Then the first to the second. Then the second to positive infinity. So that's what a or equal to or not equals with 2 things looks like. You have to go from negative infinity to the first to second, and by first I mean smaller, and then the larger one to positive infinity. Interval notation has to go in order from least to greatest. You can never put negative infinity at the end. So if you're starting at negative infinity, it has to come first. It's always least to greatest as you go from left to right. Questions on interval notation before we get into the domain part of it? All right, now we do both. So A, well, the directions say find the domain of the function. Look at A. Is there a restriction here? Yes. What is it? Good. Denominator cannot be 0. So x cannot equal negative 1. In interval notation, that's negative infinity to negative 1. Parentheses on the negative 1 because it can't include it. Union negative 1 to positive infinity. So WebAssign wants it in interval notation. You'll answer these in interval notation on your test. Go to B. Is there a restriction there? What is it? Good. Square root has to be? Good. Greater than or equal to 0. So x has to be greater than or equal to -3. That's a bracket on the -3 to positive infinity. Infinity always gets a parentheses because it's not a number you can include. I can't give you infinity dollars, right? It's not a number. Okay, go to C. What's the restriction here? Good. So how does that change it? Good. Has to be greater than 0. Can no longer equal 0. So x would be greater than -4. Parentheses on -4 to positive infinity. Parentheses on the infinity. And the last one has 2 restrictions. The square root in the top can't be negative, and the square root in the bottom can't be negative or 0. So I set the numerator greater than or equal to 0, and I set the denominator greater than 0. The numerator means x has to be greater than or equal to -4, and the denominator, 2x, would have to be greater than -1. And x would have to be greater than -1/2. Now this is like an and statement. I only can keep where it overlaps. So I need the more restricted one, okay, or the more narrow one. If it's hard to see, put it on a number line. From -4 to positive infinity would be a bracket pointing to the right. From -1/2 to positive infinity would be a parentheses pointing toward the right. And only where they overlap is what I can keep, which means parentheses on the 1/2 pointing towards the right, or -1/2 to positive infinity. Questions on domain? Yeah.
So you should really get rid of the 4, the -4.
Yeah, because it would work in the in the top, but it would fail the bottom. It would be a negative underneath the square root. So you need the more restricted one. All right, last thing in this section is called difference quotient. So everything up to this point should have seemed somewhat familiar. Like we did all that stuff in Algebra 2 Honors, but you did not do difference quotient. Difference quotient seems a lot more complicated than it is when you break it down, okay? This expression is called the difference quotient and is something you need to memorize. It will not be given to you on your test, but you will be asked to find the difference quotient. It is f of x plus h minus f of x all over h. And it says for where h cannot equal 0. Why can't h equal 0? Good, then it'd be undefined. That's your domain restriction. So even if your answer doesn't have like h in the bottom, which it won't if you do this correctly, that will still usually be given to you at the beginning. You don't need to find that. You don't need to give that to me. It's just something that you'll see, and that's why you'll see it, okay? So we will break this down in parts. You're going to get an expression. You're going to get an f of x given to you each time, and you literally have to first find f of x plus h. You're going to take x plus h. You're going to plug it into the expression. Then you would subtract from that the original expression, and then you'll put it all over h and simplify at the end. It looks like this. Evaluate the difference quotient given this specific f of x. So the f of x is what's going to change. The difference quotient will not. So f of x plus h minus f of x all over h. Now, if you practice this with me now, you do it for homework tonight, and you do it again on the warm-up, it should be already like, I know how to do this, okay? And then you just have to be careful with your signs, I would say. So the first thing I'm going to find is f of x plus h. How would I find f of x plus h? Go back to the warm-up. What if this was a question on your warm-up? What would you have done with the x plus h? Plug it in. So it's going into both x's. And I get x plus h squared minus 2 times x plus h minus 5. Now I can either expand and FOIL that, or I can use my shortcut, which is square the first term, double the product, so positive 2xh, square the second term, then I'm going to distribute the negative 2, so minus 2x minus 2h, and then I bring down that minus 5. I cannot combine terms. There's nothing there to combine. So that whole thing takes the place of my f of x plus h. Then I want to subtract from it my f of x, which was this whole original thing. So I'm going to take that f of x plus h. I'm going to subtract from it x squared minus 2x minus 5. And then I'm going to put it all over h. So I'm going to rewrite the numerator distributing this negative. I get x squared plus 2xh plus h squared minus 2x minus 2h minus 5 minus x squared plus 2x plus 5 all over h. Now I combine like terms. There's a positive x squared and a negative x squared. They cancel out. There's a negative 2x and a positive 2x. They cancel out. There's a negative 5 and a positive 5. They cancel out. If you do this step correctly, everything that's left will have an h. So I have 2xh plus x squared, or h squared, minus 2h. And it all goes over h. And since they all have an h, I can divide the h into all three terms. So I cancel out the first one. I make h squared go to h, and I cancel out the last one. I get 2x plus h minus 2. Fun stuff, right? So fun. Be careful with your signs. That's the biggest mistake people made. You should always be able to cancel out the h. Like from this step to this step, when you combine like terms, all the ones that don't have an x should cancel out. And then you should be able to get rid of the h in the bottom every time. All right, you try the next one. All right, so the first thing I'm going to find is f of x plus h. I'm plugging that into both spots. X plus h squared plus 3 times x plus h minus 2. We're going to do x plus h squared a lot. So if you want to memorize it, feel free. It is x squared plus 2xh plus h squared. I'm going to distribute the 3 plus 3x plus 3h minus 2. Then I'm going to subtract from it my whole original expression. I'm going to change the signs this time instead of doing it in 2 steps. So I'm going to do a negative on each of them, which means negative x squared, negative 3x, and then negative times negative 2 is already... That's already negative. It's changing the sign. It's going to all go over h, but I'm going to wait till the next step because I'm going to cancel from here. X squared minus x squared. Positive 3x, negative 2, positive 2, and I get 2xh plus h squared plus 3h all over h. And the h's cancel, and I get 2x plus h plus 3. Raise your hand if you got it right. Good job. Okay, the order won't matter when you type that in on WebAssign. You can just leave it the way that it is. You don't need to rearrange it. You can type it in the way that it is. Okay. but you will have to type it in. All right, homework is on web assign. Hopefully you started it. Otherwise, tonight's going to be lovely. Okay, it's due tomorrow.